description on the fitting process of the Mercer Universal Prosthetic, and then tell you what F-Scan is, which is the software that we've been using to analyze data from patients in Vietnam, and show you the analysis that we did on patients, and also discuss our future plans for this work.
So I'm sure all of you have heard a little bit about the Mercer on Mission Vietnam trip, but to just quickly go through what it is, it's just each summer, Dr. Vo takes a small group of students over to Vietnam and fits the universal Mercer prosthetic design on amputees that we see there. And over the past 4 years, over 400 patients have been fit. And those patients include all types of amputees. There's male patients, female patients. We fit people as young as 8 years old to elderly in their 60s or 70s. You're going to fit patients that have been amputated above the knee, below the knee, patients that have lost both limbs. You're going to fit patients that have their whole leg except for they've been amputated at the ankle, or maybe even patients that have only gotten like the front of their foot amputated. There's just so many types of amputees, and we've fit them all, and it's hard to collect data on each one.
Okay, so when we're fitting a patient, we start out by taking measurements of their residual limb. We take the circumference, the length from the knee to the end of the stump, and we also record information on when they were amputated, how old they are, their gender, so that we can use this information later to formulate trends and patterns in the data. And the first step that's important, you can see in this picture, I'm trying to determine a socket that fits this patient. It's the most important step, is to find a socket that fits based on the circumference and the length of the stump. And after we get all the generic parts picked out, the foot, the pylon, and the socket for the patient, we make modifications to determine their limb length, and we make adjustments if they're bow-legged or knock-kneed, and just make modifications to determine the biomechanics for the specific patient. And once all these modifications are finalized, we get Dr. Vo to visually inspect our work, and once he signs off, then we go to the next step.
So for every single patient, Dr. Vo has to visually inspect their gait to make sure that it's a natural, smooth, well-fit prosthetic so that he can sign them off to leave. But that's not a good way to put it in like papers, or to present, or to have like a lump sum of data to present to show that the prosthetic was fit properly. You can't just have a ton of video files on every single patient and just show them. So a way to quantitatively measure, they've been trying to use the F-Scan system, especially last summer in 2012, to collect pressure readings of the patient's foot as they walk, and that's one quantitative way to show how well fit a patient is. And what the F-Scan system is, like I said, it's just a thin little pressure sensor that you will place in each shoe. So as they walk, you'll see how their pressure is put along that thin sensor. And here's
So here's an example of a patient who is a below-knee left leg amputee. And good signs of a prosthetic fitting is that the trajectory of the pressure is in a straight line, and the pressure is even between both feet. So you can see the design of Dr. Vo's prosthetic foot. It accounts for the arch, similar to the regular foot, and the pressure is relatively even between these 2 feet. So this is a good fitting. And here's a patient who is hooked up to the F-Scan. They're collecting their data.
So what the program we use it'll take the pressure data that we took, and it can put it in different formats to even further analyze. And this is called force versus time analysis. What it takes is it will take the forces that you put on each foot, and it'll graph it as a function of time. So red right here represents the left foot, the prosthetic, and green represents the residual limb, or the natural foot. And what you're going to see, a sign of a good prosthetic fit is you'll see 2 distinct spikes, which represents like heel strike and toe off. So you'll see like higher pressure points there. And another thing you're looking for a good prosthetic fit is even what they call zero force time, which is the amount of time that zero force is being applied to the pressure, because that represents the time that you'll be in swing phase. So if the prosthetic is well fit and the patient has a natural gait, you'll see an even swing phase between each leg. And this one's fairly even, so this one would be a good prosthetic fit. Another form of analysis that we could use is called the force versus percentage analysis. And what it'll take is it'll take the pressure sensor, and it'll divide it into percentages based on distance. Where at the heel, you're going to be at 0%, and at the toes or at the top of the foot, that's going to be 100%. So it'll take the forces and it'll apply it like this is how much force is being applied to the heel, and as you shift to the middle, it's going to flatten out, and as you go towards the metatarsals in the front of the feet, you're going to get more force. So it's kind of like showing like the heel strike and toe off. This one was not as, like the example that we used here, was not as well a fit. The green is still the residual limb. That shows a good heel strike toe off, but the prosthetic foot, you see a little reduction in the heel force.
So our future plans, over the summer we collected about 80 patients worth of data, and a lot of it was not we couldn't use it because we just didn't get good force versus time graphs out, and we would have folds in the sensors, or it just didn't show up correctly. And so our goal for this next summer is to collect more F-scan data that we can use in the future to formulate trends based on gender, age. Every year we make modifications to the prosthetic so we can formulate whether one year's prosthetic is better than another's based on the F-scan data that we collect. And also amputee types, so like Matt was saying earlier, whether it's bilateral, above knee, below knee, ankle disarticulation, forefoot disarticulation. And we also want to improve the F-scan data collection process. We fit patients ranging from 2 hours to all day. It could be 8, 9 hours to fit one patient. Some patients have to come back for a second day to be fit. And so the last thing we want to do is keep them another hour to collect 30 seconds worth of data. So our future plans is to improve that process. So in Vietnam we'll have shortcuts and anything to make it easier for us to collect that data so we can get the patients on their way. And we also want to combine the gait analysis with the F-scan with other 3D video motion analysis programs. We have a new 3D device in the engineering building, and we also can use Logger Pro for analysis. Questions?
I had a question about your data. You said you didn't have a lot of workable data.
Well, we collected at like 80, like even though.
Yes, you said there were 80 people, and when you said some of the data wasn't good, I heard the mention of a sensor failures, which obviously that would throw those out. But when you said workable data, does that imply that some of the data indicated you didn't have a good fit, or you just didn't have confidence that it was quality data?
Well, sometimes when we fit over there, we're just trying to get them out, and there was an issue with calibration for some reason. Like on the F-scan, there's like a little data hub thing, and we recently just bought a new one, so that would be used this summer. But the last one that we had, it would just have calibration issues. Like it would
so the
say
data wasn't reliable. I would say don't use the word workable, use the word reliable.
Okay.
Like you didn't have quality data. Because it sort of implied that maybe you didn't like the way the data looked, so you didn't want to use it.
Okay.
Yeah. So, and it's important if you find out, you may find a trend, you may not find a trend, and if both of those are findings. So, anyone else? Well, thank you. Davis, if you would cue up your presentation.